Namaste everyone. In this video, we're going to see the coupler curves, how to find the coupler curves. And this here, you can see it's a 4-bar mechanism. So all the dimensions have been defined here. This length is the crank of length A. This length here is fixed of length D. This is a rocker of length C. Here we have the coupler, which is of length B. And now what we are doing is we are changing the shape of the coupler, making it into a triangle. And we get a point here, and this point is what we are tracing. And when the mechanism is rotating, this point is going to trace this particular path, and this path is called as the coupler curve. So let us just see how this actually happens, how the motion actually happens. I have prepared this mechanism here in AutoCAD, and you can see that as the crank rotates, this point here is traveling on that particular path. So it is going down, it's still following the path. When it's coming over to this side, you can see it's still on the path, and you can actually go ahead and continue moving it anywhere. So in any position, in any of the position, this point over here will always remain on this particular path, and hence this path is called as the coupler curve. Now here our challenge in this particular video is to find an equation for the coordinates of this particular point, and so that once we find these points, we are going to use either a programming language or Google Sheet to generate the equation for this complete curve, and we will be able to find a number of points on this coupler curve, joining which we are going to get this particular curve. So here I have taken that particular mechanism. You can see I have marked out all the lengths accordingly over here, and now we are going to use the trigonometric relations to find the coordinates of this point. Let's call that point as P. Let me call this the coordinates as XE and YE. So we are supposed to find the coordinates XE and YE. So let us see what the formula is for finding these two coordinates. So for this, let's draw a vertical line from this point here and this point here. So we are going to get right-angled triangles here, and we know the angle, one of the angles that are there in this right-angled triangles, and so it becomes very easy for us to find these coordinates. So for finding x coordinate, we have to add this length with this length. Fine. So you can see that in this triangle, we have this angle that is equal to theta. So this length, the x coordinate, is going to be a times cos of the angle, which is theta. So this length needs to be added to this particular length. So in order to find that length, we have to use this angle here, which is total angle alpha plus beta. And the length here is E, so we have to use that. So E times cos of the total angle, which is alpha plus beta. So these two lengths, they need to be added up together in order to give us the total coordinate XE. Now similarly for YE, we'll have to add this length here with this length over there. So once again, we have right angle triangles, so we're going to use the sine values. So a sine theta plus E times sine of alpha plus beta. So these are the formulae which we can use to find the coordinates. So but here comes the challenge. All the link lengths are going to be provided to us along with the value of theta. Theta is of course variable. We may have to calculate the values of XE and YE for different angles from 0 to 360 number of points we have to take, and accordingly we have to find this. So the thing is that A will be given to us, theta will be known, E value is again a link length which is given to us, alpha is a link angle, so it's going to remain constant and will be provided to us. Beta, however, is unknown. Right. So in order to use this equation properly, we would need the value of beta. So let's now try to find the angle beta. So we are going to use this particular triangle, and we are going to apply cosine rule in this. Okay, we're going to use that angle and apply cosine rule in this in order to find beta. So we are going to take this particular angle, so we will get cos of beta plus gamma, that will be equal to b square plus f square minus c square. So what this f is this diagonal length over here. B is this length of the coupler, and c of course is this rocker length, total rocker length. So according to cosine rule, cos of this particular angle is b square plus f square minus c square divided by 2 times bf. So if you haven't actually understood what the cosine rule is and how it is applied in a triangle, maybe you can let me know in the comments below, and I'll make another video and provide a link to that in the description to this particular video in future sometime. Okay, so we now have a relation for beta and gamma. So we know all these lengths. F again is an unknown. It's going to vary, and we don't know the value of it as of now. So b is known, c is known, b here is again known. Here we have f value that we still need to calculate, and of course we also have to calculate the value of gamma. Only when these two values are calculated and substituted here, we are going to be able to find the value of beta. So we can just transfer all the other terms to the other side. To get the relation for beta, we'll have to take cos inverse of this whole term as it is. And then because gamma is also on this side, we'll just have to subtract gamma. So this here becomes the equation for beta. So here again, we don't know the value of f, and we don't know the value of gamma, which we'll have to find it using some other methods. And now to find the value of gamma, we'll just take this horizontal line over here. We'll just take this horizontal line over here, and because this line as well is horizontal, we get alternate interior angles to be equal. So the same angle gamma comes over here. Now let's focus our attention on this particular triangle. Fine. So let's take tan of gamma in this particular triangle. So that tan of gamma will be equal to opposite length, just this, and that we have calculated that value earlier as well. It is a times sine of angle theta divided by this length. Fine. So this length over here. So in order to find this length, we'll have to take the total length d, which is this, minus this particular length, and this length is a times cos of theta. So here you can see a value is known, theta is known, d is known, a and theta, everything here is known. So we'll be able to find the value of gamma, and once we find the value of gamma, we can just substitute that over here. Next we'll have to find the value of f. So for finding f, again we are going to use the cosine rule, and applying the cosine rule for f, we'll get the f square formula as a square plus d square minus 2 times ad into cos of theta. So here you might want to be careful that you must know that we have applied the cosine rule on this particular triangle. Okay, so this will give us the value of f. So now again, taking this value, we'll just have to substitute wherever f is unknown, and thus substituting these two values, we are going to get the value of beta. And once you get the value of beta, we can substitute this beta over here. So we'll have to do the calculations from bottom to the top, and in this order, if we are doing all the calculations properly, we will be able to find values of xe and ye. Okay, so now that the calculations are very complex, in order to, at the most, we'll be able to find 2 or 3 points within the span of time which is given to us in the examinations to solve this particular problem. But I was able to use Excel sheet here, which you can see, and I was able to feed all these formulae in, and was able to find the coordinates of xe and ye for a number of different angles of theta. You can see I've taken theta values from 0 to 360 degrees at an interval of 10 degrees. So I'm getting a total of 36 points. 36 points I'm able to get here, and these 36 points I'll just be able to put this in a graph right here, and thus I'll be able to draw the coupler curve. In fact, that is exactly how I was able to, obtain all these points, and I was able to join all these points smoothly in order to get the coupler curve. But just to verify that our coupler curve, the formula that we have fed here, are actually going to work out correctly, let's take a different iteration of the same coupler, same mechanism. So I'm just going to delete all these values and also the coupler curve. Now let me change the length slightly so that we'll be able to verify these things. So here are all the parametric dimensions, and let's slightly modify this. Let me make this 40. This length, I'm just going to make it 70. This length over here, let me just make it 100. I think 100 is going to be too wide. In order to make it balanced, let me increase this value to something like 130. Okay, and okay, E and alpha, I'm going to keep it as the same. Let's go ahead and feed these lengths in our graph, in our Google Sheet. So we can see A length, I have changed it to 40. B length, we have changed it to 70. C length, I have changed it to 100. D length, I have changed it to 130. And E length is 830. It is 30. And alpha, okay, sorry, yeah, alpha angle is actually taken it as 40 degrees. Fine. Theta, I'm going to be taking the same 36 points I'm going to get, and of course okay, so all these values have changed at the bottom as well. So okay, all the formula were already fed into this, so it has already calculated whatever values we actually needed. So these are the x and y coordinates, x coordinate and y coordinate, and these points I should be able to feed it here in order to get our coupler curve. So let me copy all these coordinates and let me give the command point and feed all these points. Okay, so now that you can see that all the points have been created, let's if we want, we can just join all these points by using a smooth polyline, or you can just verify it by moving this, and you will see that this point on the coupler end is indeed actually passing through all these points that we have calculated. Fine. So this is how we are going to do analysis of coupler curves, and in the next video we're going to see how these coupler curves are going to be traced by two additional 4-bar mechanisms. Every coupler curve is in fact possible to trace by two additional 4-bar linkages, and these two additional mechanisms are called as the cognate linkages or cognate mechanisms. We're going to see that in another video, and if you felt that any part of this particular video was not understandable to you, you can let me know in the comments section, and I'll probably try to help you out with that doubt clearance. So thank you for watching this video. Please share it to all your friends who might be in need of this, and hope I'll see you again in the next video of mine. Goodbye.